Next, please welcome Mr. Tommy Tse, Customer Solutions Architect, Application Modernization, Google Cloud, to the stage.
Hi, everyone. Welcome to my session. So this session is all about containers. So who doesn't know containers, then you should think twice whether you should join this session. But anyway, so I'm a customer solution architect at Google Cloud, helping our customer to build modern applications like cloud-native container applications on Google Cloud. So in this session, I'm going to share 6 key advancements on GKE and Cloud Run. So by the end of this session, hopefully you have a better understanding of how to run your, say, AI-enabled workload as well as the traditional applications efficiently on our managed container platform. So at Google, we run our global scale services on billions of containers. So think about Gmail, Google Search, YouTube. And in fact, some of our GCP managed services are using GKE, like Vertex AI. So this year, we are really excited to celebrate the 10th birthday of GKE. But sadly, we don't have any cake to hand out due to all the scaling issue with our catering. But I think you guys all had really big lunch already, so not to worry. But I want to say that not all Kubernetes are the same. This is quite a bold statement I want to call out here. Why? Over the past decade, Google has been the leading contributor on the open source Kubernetes ecosystem, and we are driving key innovations across the core Kubernetes capabilities. And up until recently, we are focusing a lot on the platform to the platform to meet the new sophisticated demand of AI ML use cases. So there's one example I want to say. Training a large model requires massive AI supercomputing power, which is distributed across a large cluster with many accelerator chips. So GKE provides a great orchestration layer to seamlessly manage compute as well as accelerator chips. Say for the compute nodes, we can support up to 65K. And together with the multi-slicing of TPU, we allow you to chain all these TPU slices together to function as a whole, and that you can use, say, 50K of TPU v5e to train the largest distributed, to train a model across a large compute cluster. So let's get into the 6 key advancements I want to cover today. So first of all, inference gateway. So this is a new feature that we announced very recently. And first of all, traditional load balancing algorithm is not suitable for AI inferencing. And for AI optimized load balancing, it can drive 60% lower latency and 40% of high throughput. And also, you can serve dynamic LoRa models on a single accelerator, so that reduces the number of TPUs or GPUs required. And also, that could save up to 30%. Later on, we will bring the support of multi-region GPU, TPU capacity tracing. And last but not least, all this inference gateway feature is integrated with our model armor and also cloud observability, so that you have a consistent protection of all the models in the cluster, and also it's extendable to third-party ISV solution. And it has protection of the robust top 10 for LLM applications, with centralized visibility and control for security and platform teams. So on the traditional load balancing, the problem is you will end up with hot spotting or across some of your accelerator or GPU or TPU, and that would end up a lot of wastage of the accelerator that you provision. But with inference gateway, it routes according to the metrics from your inference servers, say the KV cache utilization and also the pending queue. So that overall, it will save up the cost of up to 30% and the tail latency up to 60%. And on the capacity chasing of GPU TPU that will be coming soon. And this is actually enabled by the multi-cluster orchestration to schedule AI inference workload across multiple clusters, across different regions. And together with the support of multi-cluster gateway in GKE for cross-region layer 7 load balancing. Okay, on the second advancement, I just want to know, has anyone heard of custom compute class on GKE, or has anyone used it? Can you raise any hand? Or not many people, okay. I think this is a really key feature that I want everyone to be aware of. And I find out when I speak to many customers, they are not aware of this feature. And actually, this was announced last year around August. So let me quickly explain what is CCC, or custom compute class in GKE. So this is one example. So you get, I want to say run some workload, but my priority is on N4 family, machine type, or with a spot instance. But if there's not enough capacity, then I want to run it on N4 standard. And if there's none, then I will run on the default E2. So this is the YAML specification that we can define with custom compute class. So first of all, CCC will use node auto provisioning to create 3 different node pools in this example. And when there's like capacity for N4 spot, then we try to provision on the spot node pool. And say my workload requires more node, but it's not available. Then what happens next? The cluster autoscaler will add the next priority nodes. That's the N4 standard nodes from the available compute pool here. And when there's a spot instance becomes available, then active migration within CCC will do the switch over for you automatically behind the scene, so that you always get a rebalancing of your preferred priority of the spot instances for you most of the time. So this is another example of have your priority of spot instances. If not, then fall back to C4 and then subsequently to N4 and so on. So this is just another example here. And also you can integrate, as in add your GPU reservation in CCC, so that you can always ask the cluster to use your reservation. If there's runs of capacity, then you will look for the next any reservation across the project, or any spot instances are available. So this is one custom example from Shopify. So they leverage custom compute class during the last year Black Friday Cyber Monday event. And you can take a look at the metrics here. They're able to serve like over 1.19 trillion of edge requests. And they're talking about the request per minute is like 284 million. So it's huge. And what they did is they customize the rules of using CCC on a per region basis to ensure that they're optimizing the best price performance ratio for each of the region. And they can ensure they can scale to handle whatever traffic comes in. Okay, the next feature is COC. Content optimized compute. This is a new thing that we are introducing this year. And actually, this is a multi-year investment we're doing on the product. So the mission here is to give you the near real-time, vertically, horizontally scalable compute that provides capacity you need, and when you need it, and where you need it, at the best price and performance. There are several advancements I want to cover here that is done across the entire GKE stack. So the first thing we did is the cluster autoscaler. So since GKE 1.29, you were able to schedule port with say a P95 scheduling time reduction of up to 85%. It's amazing. And secondly, we did some improvement on the HPA, horizontal port autoscaler. Starting from GKE 1.31, we were able to make it react faster up to 2 times. And you can support up to 1,000 HPA objects in the cluster. So let me show you a couple of demos. Hopefully, it's going to be really fast because it's a pre-record. I just want to save time so they can have a feel what's the before and after of the improvement we did. So this is on the old version of GKE. Okay, let's play this. Is it playing? Oh, it's not playing. Okay. Oh, okay. Sorry, let's go back to it. It's a glitch here. Okay. Looks like it's not playing. Okay, let's forget about the demo. I think let me show you what actually happened. I've got a, can you just click on this? Okay, can I just go back to here? Okay, let's do it again. Okay, yeah, that's what. All right, this is on the old version of GK, where I want to scale a deployment to a 10 replica, and say on an autopilot cluster, it takes around more than a minute. It's almost 2 minutes. But with COC in the new cluster, doing the same thing of 10 replica, this is the old video, sorry. You need to move to the next one, sorry. Yeah, it can't be that long, right? Because it has to be improved for sure. So I'm glad you guys are listening. Okay, this is the improved version. And yeah, you can see 7, yeah. So it's like 10 seconds to scale to 10 replica. Okay, but what matters to your user is the actual serving latency. I think the next demo will have a better representation. So let's look at this one. So I have a load generator doing something similar, but with a HPA enabled in the cluster with this deployment. And you can see, I mean, this number is not the most important because this is like, you can see all those pending replica becomes running really quickly within seconds. And then you can scale to many of them. But I mean, this is only matter for your the platform, your DevOps engineer, but not your customer. What your customer actually seeing is the latency improvement. This. So it's like less than 1 second, even for P50, P95. And we can sustain the load for that. And you can see a comparison. This is the new stack, and there's the old stack. The new stack is like, say, P50, 0.2. And the old stack is 0.9, so you can see almost 4x improvement across P50, P90. Even down to like P99 is down from 2.7 seconds to 0.9, so 3x. It's pretty impressive, I would say. And what's upcoming? In the open source Kubernetes, there's a thing called IPPR, in-place port resizing. So what it does is you can update the port request, say CPU memory source, without restarting the port. And what actually this enables is we are building a feature called CPU boost. If you are familiar with Cloud Run, you probably tried CPU boost before, and actually we are bringing that to GKE. And that's really helpful for like Java application that's like resource hungry, like Spring Boot apps. There's a lot of dependency injection at the beginning, so that takes a lot of resource. Maybe you might need like 2 or 4 cores at the beginning, but you just only need, say, half of it when it's running. So this is going to be a feature we see that's coming in the next 2 to 3 months. So watch out for this. Okay, so this first half of this talk, what I cover is the inference gateway to help with, it's a Gen AI aware load balancing to give you better efficiency of using your accelerator, GPU, TPU. Secondly, on CCC, custom compute class, where you can prioritize the kind of machine, the nodes that you want. And it's a Kubernetes native API that is just defined in a YAML manifest. And thirdly is COC, what I just showed in the demo, of better response, scalability, and so on. Okay. Let's switch gear to Cloud Run. As I mentioned, this Cloud Run for CPU boost. Has anyone used Cloud Run? I think some people might. Cloud Run is good. Yeah. Okay. Yeah. So if you don't know what Cloud Run is, it's It's a fully managed serverless platform that you can bring your code, your functions, your containers, and run it on our Google infrastructure. So it is really fast auto-scaling, and it can scale from 0 to something, whatever you need, and back to 0. It's integrated with the rest of the GCP platform, like Secret Manager, Cloud Monitoring, Cloud Storage, IAM, etc. And that you can fully participate in your advanced networking and security across your, say, compute engine VMs and also GKE applications. And thirdly is amongst the developers, we see there's a top certification and usability scores, and they find it really simple to start with, and you don't need to manage like the VM or infrastructure or cluster anymore. And you might have a question asked, is serverless or something like that, is it enterprise ready? Certainly yes. Why? It's like we have it security, all the networking stuff built in with it, and also is complying with major certifications such as PCI, ISO, SOC, and you can run a range of workloads, including AI inferencing, which I'm going to talk about in a moment, web serving, API backends, data processing. There's many things you can run on Cloud Run, and it supports both public and private workload. And thirdly, it's really cost effective. You don't need to pre-provision for peak traffic. As I said, it can scale down to 0, you don't need it, and it has built-in zone node redundancy out of the box, so you don't need to even like over-provision across different zones. And beyond that, we have different building model, and also supports COD, the computer use discount. And across, since we GA Cloud Run back in 2019, there's a lot of features that we rolled out in the past years. There's so many, there's a lot. But let me pick 3 things and just talk about in a moment. Okay, I have to talk about AI because AI is the important thing. But actually, I want to say Cloud Run is a really good runtime for AI agents. Why? It's like, you can, I mean, for typical AI agent architecture, you need a model for the reasoning. So you can use our Gemini model or any model on our model on Vertex AI, and as well as I said, you can do AI inferencing on Cloud Run. So you can actually get an open model from Hugging Face and deploy it to Cloud Run. And apart from the reasoning part, the agent needs to store the context, the memory, so that you have a continuous conversation with the user. And also it does the orchestration with tools, so for grant the information. As I said, Cloud Run is a great runtime for that because you can deploy any agent framework, say LangGraph or even ADK. And it has built-in GCP credentials so that you just use IAM and service account to authenticate with different services. And as I said, it's very scalable. You can scale from 0 to something and back to 0. Okay. Cloud Run GPU is the thing I want to talk about. So it shares a similar characteristic with CPU in Cloud Run, so that you can scale on demand, scale 0 very fast, and pay by second. And it's available not just 4 regions, at the 5th region, now 5 regions. The typical use case is you can do LLM inferencing, and also you can do image generation, and also media processing with Cloud Run GPU. So 5 seconds is like we can scale the instance from nothing with the GPU attached and also the driver installed in the Cloud Run instance. If you do it on the VM, it takes like, I don't know, maybe after a minute or 2. And together with loading the model and starting the inference server, we typically see like 19 seconds or 20 seconds for a Gemma 3 model running on Cloud Run. So it's pretty impressive. Okay, let's give you one demo on a stable diffusion scaling on Cloud Run. So I have a stable diffusion inference service deployed in Cloud Run. It's using TorchServe. And I've got one NVIDIA L4 attached to that. So there's 2 containers. One is an ingress sidecar, and I set all the instances with 1 concurrency and up to 200 instances for this. And initially, I've just need to create just get the URL for Cloud Run here. So that's set the environment variable of a load generator locally here. And with an image output that the stable diffusion will generate the images. And there's a prompt file with a list of prompts that I'm just feed into the load generator of the image output. So this is a list of prompts of various of cats images that I want. So what I need to do here is just to start the load generator. I start with one client. And it immediately responds to some images here. So it's a fluffy Persian cat, and I see the images across in this output folder, and it's the cat. I mean, the most interesting part is not this. It's after. I'm going to scale the load generator here for not just one client, but up to, say, 100 clients, and run it every 2 seconds. And let's take a look at the output here. And it's starting right now, and this is the display. And I can, when you scale out, you spin up more instances on Cloud Run, and then you will, for each instance, you will get like a new GPU for that. And the latency is around 20 seconds for 20-something seconds for generated image with stable diffusion. That's pretty cool. Yeah. Okay. So this is what a custom reference from Vivo. So Vivo, you may be familiar, they're a smartphone manufacturer. So they're using Cloud Run to do something similar, what I did here, but even more advanced. So they use Cloud Run for 3 different use cases. So first of all, they use Cloud Run CPU for like text and audio services. So for example, like doing live call translation, AI captions, note assist, this kind of like CPU intensive tasks for that. And on the second use case is they use the GPU feature I just mentioned for image processing. So features like AI erase, overlay, photo enhance, and filter is all done by Cloud Run GPU. And finally, they use Cloud Run GPU for document processing, like features like shadow removal, monoline pattern removal, table extraction. So again, this is all done like through Cloud Run and GPU. And they see that Cloud Run is a versatile, powerful platform for enabling their AI use cases across their product portfolio. Okay, the 5th feature is on Cloud Run is workables. So in Cloud Run, we already have services and jobs for supporting like various use cases I mentioned. And now we are adding a new model of running in Cloud Run is called workables. So workable provide customer with an ease of use, scalability they get from like the other Cloud Run services and jobs, especially for pool-based workload. So it's not anchored to any HTTP-driven kind of request, that kind of workload. There's some example use cases we are testing out with a customer. For example, we have Cloud Run worker pools of Kafka consumers pulling tasks from a Kafka queue. And together with the autoscaler of Kafka, as in we have an autoscaler that can read the metric from Kafka and to drive the worker pool instances, to scale that out and back in. And another use case for PubSub, where you can have a PubSub pool subscription, and then the worker pool instances will just pull the new messages from that, and we can trigger this kind of worker pool from a scheduler, like Cloud Scheduler, or even you can auto scale based on CPU, or you can manually do it. And then there are coming like more and more use cases along the way towards GA later this year. And finally, what's new for enterprise apps? I've got a couple of features I just want to cover here before we end the session. So Cloud Functions, I believe many people have used it, but now it's called Cloud Run Function. So basically, we integrate Cloud Functions into Cloud Run as one managed service. So it's already GA for Cloud Run Functions. And what's special about Cloud Run Functions versus like the traditional function as a service is it supports concurrency per instance. So what it does is like this example, I can sustain the same kind of loading requests, and because each instance can take multiple requests concurrently, so I just need less Cloud Run instances to run the same kind of workload here, and that would means a lower cost and more efficient execution of this. And IAP is about if you want to deploy a Cloud Run service internally for your employee or staff with an internal-facing front end, typically what you need to do is to add an authentication layer on top, and what you can do is using IAP. In the past, you want to enable IAP with Cloud Run, you need to have a load balancer, but now you don't need to. You just click a button, and that's it. And that saves you the load balancing cost. And Cloud Run threat detection, it continuously monitors the state of your running instances, and if there's any unusual behavior, let's say remote access, vulnerabilities, etc., and you can detect and investigate that. And it's integrated with a security command center so that you can resolve any immediate security concern there. Okay. On the high HA architecture on Cloud Run. So Cloud Run is actually a regional service. And we handle replication like within the region, across different zones. It's all built in. So it's good enough for many use cases, but for some customers, they just want more. So if you want to run like multi-region deployment to increase, say, the uptime and decrease the latency, what you can now is to use a single command like this, the G-Cloud Run deploy across different regions, and then you can deploy the same Cloud Run service across multiple regions. And what's coming soon is we're going to add a cross-region failover. So what you can do is you add a readiness probe on Cloud Run, and then if this readiness probe fails, it will automatically fail over to the other region. So the end user can still get a better availability for the service here. All right, so that's the last part, just a summary. So I covered Cloud Run GPU. It's GA already. Just give it a try. And also, you don't need to request like a large quota now because everyone can get a minimum quota to start with Cloud Run GPU. And secondly is on worker pools for the new pool-based workload. And also, I'll cover quite a few enterprise features that will be really useful, especially the HA part and the security and the networking. And thank you for listening. If you got any questions, want to talk to me, I'm just around. Feel free to grab me. Anything to do with GKE, Cloud Run, anything for building modern applications on GCP. Yeah.